In today's lecture, we will discuss about how two atoms interact in a solid. They are either held together, either a metallic bond or covalent bond or ionic bond. A compound, sodium chloride, very common compound, right? And this sodium is ionized in sodium ion plus an electron. For this process to occur, we have to supply energy, which is around 1.5 electron volt. Since we have to supply energy, we write this as a positive sign. And this energy is called ionization energy. Likewise, we have chlorine atom. It take one electron, become chloride ion, and this in terms release energy. That's so we write it as a negative. This energy is known as electron affinity. If we combine this or sum up, we will get 1.4 electron volt energy, and that too the positive. Now we have sodium, which is positively charged, and negative chlorine, which is negatively charged. So one entity is positive and another entity is negative. So they bound to interact with each other through Coulombic interaction. So there will be attractive force and electric energy. We called it E, and this will be 1 upon 4 pi epsilon E square by R, as we know, and this will be negative. So they are interactive one is positive charge, negatively charged. So overall it will be negative. We call it equation 1, right? So this is attractive. Now this sodium ion also have electron, inner shell electron, right? These are inner shell electron and they are negatively charged. The chlorine also have inner shell electron. They are also negatively charged in their electron. Since now they are coming close and close, now this negative charge and the inner shell of negative charge of the chlorine, they will start to repel each other. So this energy will be positive. This energy will be repulsive, and it is given by 1 b upon where b is a constant upon r to the power n, where r is usually around 10. So it will be E will be around p upon r to the power 10, and this will be repulsive. Now we have two kind of interaction. One is attracting, one positive charge is attracted to negative charge, and second interaction is repulsive interaction, which is really between repulsion between negative and negative. So there are two forces that are working together. So there will be an equilibrium where these are balancing each other. Now, to get better idea or more better visualization, I am going to plot these two equation together. So to start with, as explained, why this is R on y-axis, we have energy. Now there are two terms which was plus 1.4 electron volt, right? Which we added when we added for plus 5.1 electron and negative 3.7 electron, we got 1.4 electron volt. The second term was attractive term, which was minus 1 upon 4 pi epsilon E square upon R, right? This was one. and the second was 1 upon V by R to the power 10, right? So since first term it will be independent, so it will be straight line. It is 1.4 electron volt, right? Now this first term, it varies as a 1 upon R. Like if R is increasing, E will decrease, and at when R is infinitive, it will be 0. So if we plot this, this will look like something like this. It will be minus 1 upon 4 pi epsilon E square upon R. So this is first term. The second term, which is positive, and it increases R to the power 10, which is very high, which means when R is very small, the E, it will goes to very high value. So there will be very sharp jump. So this will be something like this. So it will be like P upon R to the power 10. So when we combine all these three curves or items, we will get the resultant curve will look something like this one. And it start to decrease when the negative terms start to take into effect. Then suddenly there is a sharp increase. This is the overall effect. So when the energy is most negative, it's like E naught, and the corresponding distance R naught. So this is the equilibrium distance when attractive force and repulsive force are balancing each other. So it will be the equilibrium distance between these two atoms. This is for the case when temperature T equal to 0 Kelvin. Now, what happen when we increase the temperature of a material? So, atom inside this material will start to vibrate. What will happen? The energy of the system will increase. So, it will be even. So, with this corresponding to energy, there are two positions like this, either this or this. So, they start to vibrate. This correspond to temperature T1. If we increase the temperature further, let's say this T2, then they will vibrate more with corresponding to this energy. Similarly, for let's say for T3, corresponding to the temperature of T3. On an average, the mean position of the atom where the temperature increases is shifting towards right. So that is why when we increase the temperature, the atoms start to vibrate. So on an average, they see the more on an average increase in value of R. That has this is result when we see okay when the temperature increase, the material change its dimension. So how much a material will change its direction, which uh, dimension, which it will depend upon the shape of this curve. So the more asymmetric this curve is, the more thermal expansion it will have. For example, if a material has a curve, this curve very symmetric, right, like this. So the on an average distance between these two will be same. So it means the these two and this side and this end will be same, which means when we increase the temperature, on an average, we will not see any dimension change or expansion. While in other case, if the material is very asymmetric like this, then if you on an average value, if we see the mid distance average value will be different. So it means the the material will be elongated. So this has resulted into the change in the dimension.